Okay, so it sounds like most of you are finishing this one, or finished. So if I'm negative, where are the angles going to be for cosine? Quadrants 2 and 3. So over here and over here. Okay. Then, which triangle has these pieces? The first one, which looks like this. 1, 1, root 2, and 45 for both angles. So now what I have to ask myself is, the reference angle this time, it says it's 45 degrees. So theta reference is 45 degrees. Okay. So what is this angle over here? 135 degrees, because the rest of it, if I added 45, gets me to 180. Okay. There's 45 for the reference angle, so what's this angle right here? 225 is correct. So that tells me what my two angles are. One is 135, the other is 225. Okay. So what we want to do now is we want to try answering with radians. Dun dun dun. Okay, so radians, don't let them scare you. They're basically just another way like kilometers and miles. But if when you find your answers this time, I'd like them to be from 0 to 2 pi instead of 0 to 360. So in Math 12, your goal is going to be to work completely in radians. That's what your target will be. So see if you can try that for one of these questions here. Try at least one of them not converting to degrees. See if you can work your way through the whole question in radians. Okay, so for the first one, this is the triangle we should be referring to. The one that has the side lengths 1 and 2 in it. So root 3 is the other piece, 30 and 60. The angle is positive, so sine is going to have two angles, one in quadrant 1, one in quadrant 2. So if I look for 1/2, the opposite and hypotenuse is going to be 30 degrees. So 30 degrees, how much is that in radians? Pi over 6, excellent. So let's come up with our angles in radians. The first one in quadrant 1, well, it's the same as the reference. It must be pi over 6. The second one over here, any guesses?
2 pi over 6.
Well, let's put pi over 6 in here. The whole thing, where's this? How much is this whole thing worth if I go all the way out to here? That's just pi, right? Just pi when I go to there. So pi minus pi over 6 will put me at 5 pi over 6. So those are my two answers for that question. Okay, which triangle? This one here, it's like you have two pieces in there, right? 1 divided by 1. There's no extra 1, but that's the triangle we're referring to. So the triangle that I'm going to be looking to get help from is 1, 1, root 2. And we know that both angles are 45 degrees. Okay. So what is 45 degrees if I'm in radians? Pi over 4 is correct. So pi over 4 is my reference angle. So I'll use my reference angle now. Tangent is negative. So here's where tangent is negative. There and there. So my reference angle is pi over 4. And pi over 4 here. So what would those two angles be? Let's try the first one up here. What's the top one worth?
3 pi over 4.
3 pi over 4. So the whole way would be pi, and I've taken a quarter out, so it's 3 pi over 4. Okay, how about the last one over here? How far is this?
7 pi over 4.
Yeah, 7 pi over 4. Okay, so the whole way would be 2 pi. You take a quarter away, you end up with 7 pi over 4. Okay, so these are my two answers. Okay, what about tangent undefined? How would you make tangent undefined?
Divide by 0.
Divide by 0. Okay, so that's what happened here. Somehow we divided by 0. Okay, where do we do that? So on the unit circle at 90 degrees is one of them. Why? Why is 90 degrees a problem? So the coordinates here are 0 and 1. this is the problem because the cosine of theta equals 0, which means sine divided by cosine is going to be undefined. So that's the problem, is because I've divided by 0, because the cosine is 0. Where else might I find the cosine of 0?
Down.
Yeah, down on the bottom right here. Okay, so down on the bottom, that coordinate is also 0, -1 for sine, but it's still going to divide by 0. So I have two angles, one up here at pi over 2, and one down here at 3 pi over 2. Okay. Okay. So let's take a look at this. I'm just going to show you quickly here. I don't want to beat it to death because I think we're going to practice quite a bit, but basically when we work with these equations, it's exactly the same as what we just did. So let me show you what we just did. If I rearrange this, then it goes back to what we just worked on. So that's the only thing you may have to do differently, is you may have to start with it. For example, this one is going to become 2 cos x equals -1, then cos x equals -1/2. You may need to rearrange it in order to figure out, where to start. Okay, so we won't do all 4 of them because I know we've been working on them for quite a bit already. But here's the last thing, which again, it's going to be the same as what we've already practiced when we come back to the basics of it. The trick though, however, now is there's this square. Okay, so the reason we put a square in the middle is if you did this, which one would you mean? Would you mean to do this? Oops, going to sleep there. Just hang on a sec. Okay, so it appears we've recovered from a small crash, but that's okay. So what I was trying to say here is that you may end up with this, or is it, I should say or, not equals, or you talk about sine x squared as in the x value squared. So the way the notation is used is when you see it in the middle like this, it refers to this one here. And if you didn't see it in the middle, it would be this one where you're squaring the argument that goes into it. Okay, so that's the notation. Watch how this goes. If I've got sine x squared equals to 1/4, then sine x squared equals 1/4. What would you do normally? If this was any old equation that you've solved before, what would you do with this? Say it. Yeah, I just hear mumble. I'm hearing mumbles. Just say it. Square root. Yeah, so if I square root both sides, what do I have on this side? So close. Plus minus, right. It could be positive or negative, because when I square it, it comes back to positive. Why is this important? Well, now when I'm thinking about where my values are, I have both positive and negative. So here's positives. Here's the negatives. So now I have 4 angles to find, because it can be the positive or the negative. Okay, the process is still the same. We're going to take a look at this triangle, 2, 1, √3, 30, 60. What would be my angle for x if it was 1/2? 30, right? So 30 degrees is how many radians?
Pi over 6.
Pi over 6 is correct. So here's what I do is I'm going to walk around my answers here. This is pi over 6. What will it be when I'm over here?
5 pi over 6.
5 pi over 6. And then when I go over here?
7 pi over 6.
7 pi over 6 is right. I'm taking pi and I'm adding 1/6 to go this way. Okay. And then what am I going to be over here?
11 pi over 6.
11 pi over 6. This would be 12 pi over 6. Take one away to get me down here. So 11 pi over 6. So there are actually 4 answers to this question. Okay? So you try this one. See if you can solve and find all 4 answers. Okay, so there's actually only two places where it equals to 1. The cosine equals to 1 right here, and once where it equals -1 at pi. So the two angles in radians would be 0 and pi. There is no triangle to search for the cosine. You might think this triangle, 1, 1, root 2, but you can't do that with cosine because you need to use the hypotenuse, so you don't have the right pieces. So the only other one it could be is from the unit circle. In the unit circle, those angles would be 0 and pi.